Miss Dear, you know this is my first contract where the ship uses this distillation process instead of reverse osmosis.
Really, Mr. Hall?
Yes, ma'am. Remember I was telling you earlier I've only worked on cruise ships.
Well, this is my fourth contract on board a cargo ship, and I've learned quite a lot, so I'll keep you up to speed. So, the distillation plants are basically like heat exchangers, and we know those come in two types, plate type and tube type. The principle of operation of both of them are basically the same. For optimum performance, distillation plants are mostly used when the ship is on her way, when the engine is running at navigation speed.
Oh yes, because the seawater is clear in the deep and open sea that is close to shore where the mud is shallow and may contain mud.
Yes, Mr. Hall. The heating medium used to boil the seawater is the main engine jacket water, which boils the water at only 80 to 85 degrees Celsius.
But water boils at 100 degrees.
Exactly. To boil the water, we apply the combined gas law, which states that the boiling point will decrease as atmospheric pressure decreases. And the shell is an airtight casing, which gives it the ability to create a vacuum.
Now that makes woolly sense.
Glad you're following. During the operation, the ejector pump suctions water from the seawater, the main seawater line that is, which passes through the eductor by the Venturi effect. The eductor suction line is tapped into the shell, and as fast going seawater goes through the eductor, the pressure drops, and air and other particles will be suctioned to create a vacuum, effectively lowering the atmospheric pressure inside so that the seawater will be able to boil.
Oh, I was watching a video on that to know. From the eductor, the seawater will pass through the condenser cooling tubes, which acts as the cooling medium. So in the cooling tube, the heat from the steam produced by the evaporator is absorbed. And when leaving the condenser, some of the water will return to the evaporator area, where it acts as a feed water inside the evaporator area. The feed water will pass through the tubes, heated by the jacket water until it evaporates and leave behind the salt and other heavier particles which will be discarded by the eductor.
Yes, just like that. Steam from the water being evaporated will rise and pass through the wire mesh baffle for filtration, and it comes into contact with the condenser tube. The cooling effect will cause the steam to condense, and the resulting liquid from the condensation will be collected in the liquid receiver, then suctioned by the distillation pump. The fresh water will then be sampled and analyzed by the salinometer. Here, the water purity will be determined by the absence of salt by measuring the electrical conductivity.
Oh, I see. Pure water has a high resistance to electrical flow, while salty water has a high rate of conductivity. Therefore, the higher current flow, the more salt content. Yeah.
Ah, and if the measured salinity is above 10 ppm, a magnetic valve will activate and divert the flow of fresh water back into the evaporator. But if the salinity is below 10 ppm, the water will be diverted into the ship's freshwater storage tank.
Engine control room, engine control room, engine control room. This is Second Officer Hanchard speaking from Bridge. Over.
Yes, Bridge. Go ahead.
We will be leaving Port Shanghai for the port of Kingston in approximately 1 hour. Please to get the necessary machinery ready for departure. Over.
Okay, no problem, Mr. Anchard.
Engine control room, engine control room, engine control room. This is Second Officer Hanchard speaking from bridge. Over.
Yes, Bridge. Go ahead.
We are now 20 nautical miles from land. Please give the order to start the freshwater generator. Over.
Yes, Bridge. Thank you very much.
Starting the freshwater generator. Check that the ship is not in congested water, canals, and is 20 nautical miles away from shore before starting the freshwater generator. Near the shore, the effluents from the factories and sewage are discharged into the sea and can get into the freshwater generator. Check if the engine is running above 50 revs per minute, because at low revs per minute, the temperature of the jacket water may be around 60 degrees, and that is not sufficient for the evaporation of water. Ensure that the drain valve at the bottom of the generator is in a closed position. Open the suction and discharge valves of the seawater pump, which will provide water for evaporation, cooling, and to the eductor for creating the vacuum. Open the seawater discharge valve, from where the seawater is sent back to the sea after circulated inside the freshwater generator. Close the vacuum valve situated on top of the generator. Start the seawater pump and check the pressure of the pump. The pressure generally is at about 3 to 4 bars. Wait for the vacuum to build up. It should be at least 90%, which can be seen on the gauge present on the generator. This generally takes about 10 minutes. When the vacuum is achieved, open the valve for feed water treatment. This is to prevent the formation of scales inside the plates. Open jacket water inlet and outlet valves slowly to about half, opening the outlet valve first, always. Slowly start increasing the opening of the valves until they are fully open. As the boiling temperature starts increasing and the vacuum starts dropping. When the vacuum drops to about 80%, it is an indication that the evaporation is started. Open the valve from the freshwater pump to drain. Switch on the salinometer if it has to be manually started. Generally, it is on auto start. Start the freshwater pump and taste the water coming out of the drain. When the fresh water starts producing, it can be seen that the boiling temperature starts to drop again, slightly, and the vacuum comes back to the normal value. Check if the water coming out of the salinometer is not salty, and also check the reading of the salinometer. This is done to see if the salinometer is working properly or not, to prevent all the fresh water from getting contaminated with salt water. The value of the salinometer is kept below 10 ppm. After checking the taste of the water coming out of the salinometer, open the valve for the tank from the pump and close the drain valve.
Second, there's an alarm for freshwater generator, high salt content.
Okay, understood. Chief, the salt content of the fridge is too high.
Okay. So, Mr. Hall, you're saying that the salt content in the freshwater generator is too high. Okay.
But Chief, we recently carried out some maintenance check on the condenser and the demister.
Yes, Mr. Hall, that is correct. So it is highly unlikely that it is any of those two. Okay. Mr. Hanchard, go and check the gasket cover, the front gasket cover, if there is any leakage in that part of the system, please.
It's always good to have readings about your machineries, the temperatures, the pressures, to see how they work. Here, as you can see, we start to dismantle the side covers and the top cover of the freshwater generator, and already we have pressurized our freshwater generator. As you can see, one tube here it's leaking. Everything was cleaned by soft brush, and after that was blown with air. All the surface was cleaned, and after the pressurizing of
Yes, go ahead, Mr. Anchard. Okay, so there's a leak. Now I know what the most probable cause of the fault is. It might just be that the front cover gasket is defective, and this causes a carryover of seawater into the freshwater generator. Second Engineer Hall, you know just what to do.
Cleaning. Charred or loose glue and rubber remains must be removed. Example, using a rotating stainless steel brush, the width should be adapted at diameter 40 to 50 millimeters and width 8 to 10 millimeters. Thin layers of glue which are difficult to remove may remain. Clean the gasket groove with a clean cloth dipped in a solvent, acetone or methyl ethyl ketone, etc. But be careful when handling these solvents as they may be hazardous to your health. Observe the supplier's instructions. Gaskets that are loosened can be glued on. Clean gasket groove carefully with a sharp tool. Then clean the loose part of the gasket with emery cloth or sandpaper. Finally, clean groove and gasket with a solvent and glue. Dry the new gasket with a clean cloth that has been slightly moistened with a solvent. Apply a thin layer of glue to both the gasket and groove. Let the glue dry for 10 to 15 minutes. Then fit the new gasket into the groove. Gaskets may be sometimes slightly short or long. Short gaskets should be stretched before being fitted into the groove, while long gaskets should be fitted into the grooves at the plate ends first, then gradually pushed into the groove towards the middle. If necessary, tape the gasket into the groove. Pressure testing separator. If there are leaks in the system, it will be necessary to carry out a pressure test in order to identify the leak. Close the valve on discharge side of combined cooling water ejector pump. Close the discharge valve on overboard line from combined brine air ejector. Close valve on discharge line to freshwater tanks. Open separator vessel in order to vent the vessel when supplying water for a pressure test. Supply water, seawater or freshwater, at the socket for the connection of feedwater treatment. Caution: maximum pressure on the separator vessel is 15 kilopascals or 21 psi.